Hello, my name is Ahmet Akdere, and I am a first-year mechanical engineering student at Bilkent University. In this video, I will present my Phys101 project, where I investigate how the spring constants change when two springs are connected in series and in parallel. Before explaining the experiment, I want to briefly mention the physics behind it. This project is based on Hooke's law, which states that the force applied to a spring is directly proportional to its extension. To begin the experiment, I first measure the spring constants of each spring separately to confirm their accepted values. I attached three different masses, 100 grams, 120 grams and 140 grams, to each spring and recorded the corresponding extensions. Using Hooke's law, I calculated the spring constants for each measurement and then took the average. These average values of K1 and K2 were compared with the accepted values shown in table 3 of my report, and they were reasonably close. After that, I connected the two springs in series. I repeated the same measurements with the same masses and plotted a force extension graph, shown as graph 1. From the slope of the baseline, I obtained the experimental value of K series, which was close to the theoretical prediction in table 6, with a percentage error of around 2%. Next, I connected the springs in parallel using a rigid bar and a string to attach the masses. I again measured the extensions for the same three masses and plotted graph 2. The slope of this graph gave me the experimental K parallel. This value was slightly higher than the accepted value, but it still clearly demonstrated the expected behavior. The parallel system was much stiffer than the series system, as predicted by the formulas. Now, I would like to discuss the uncertainties and errors in this experiment. Several systematic errors affected the results, including the limited precision of the ruler, slight misalignment when reading the measurements, and the weight of the string and rigid bar in the parallel setup. Since the extensions in the parallel connection were very small, even tiny measurement uncertainties had a larger effect on the percentage error, which explains why the parallel setup had a higher error percentage than the series setup, as shown in table 7. There were also random errors, such as small vibration in the stand or the spring not fully settling before the measurement. These unpredictable factors cause slight variation in the displacement readings. Overall, my results strongly supported the theoretical background of the experiment. As expected, the series connection produced a smaller equivalent spring constant, while the parallel connection produced a much larger one. The experimental results were close to the accepted values, and the percentage errors were reasonable. This shows that Hooke's law and the theoretical formulas for combining springs were well verified by my measurements. Thank you for your watching.